Hey everybody, Paul Abernathy here. Welcome to another episode here at Electrical Code Academy, where we're going to do some commentary on a video that is getting a lot of traffic on the internet. In fact, over on YouTube, this video alone has over 1 million views in about a year. The channel that puts this video out has over 555,000 subscribers, so no small channel by any means. Now, it is more tailored to the DIY, the do-it-yourselfer, the home improvement, so that part of our commentary series, as obviously very much electrical driven, is that we like to look at videos, present the commentary, see whether or not the information they're sharing is accurate, and make little tweaks where we need to. It's not in any means to belittle them or to talk down to them or not devalue the information that they have to share, because it is great information that they share. In fact, I love it when home inspectors, home improvement folks, DIYers, homeowners, I love when they learn about electrical and try to, because again, we're not going to stop them trying to do things themselves. If at any point somebody like that, DIYer, home improvement, homeowner, feels like it's just over their head, I would hope that they stop and call a professional and have an electrician come out and help them. But again, we can't stop it. It's going to happen. So since it's out there and it's shared on the internet and with over 1 million views, we want to make sure that the information they're giving is accurate. And if I need to add any additional commentary, I'm more than happy to do that and help to raise awareness of all this information. And also at the end, I'll give my 5-star rating on how well he did and add any extra commentary where necessary. Okay, so let's go on and get into it and get started. All right, here's the gentleman. Again, you see it's about a 7-minute video. I can guarantee you our video is going to be longer than 7 minutes because I'm giving commentary. But we're going and get started in his. And we'll see how it goes.
How's it going, you guys? It's Scott with Everyday Home Repairs, and today I want to quickly show you how to solve an issue that's probably been plaguing you for a while. And that is, if you live in an older house, you might have 2-prong receptacles, which are just a pain in the butt and unsafe to work with.
Now, some people will argue when they say unsafe, a 2-prong plug like that, or 2-prong receptacle device like that, is not going to have an equipment ground, obviously. So there is no return path back for current to travel. So there'll be other people that state that it's actually safer because it doesn't have an equipment ground. Now, not safer in a sense of the building and fires and tripping off an overcurrent protected device from overload, things like that. It's still going to do its overload. It's still going to do its short circuit application. But again, ground fault, obviously not so much, right? But there are people that argue that the 2-prong is safe, but it is not very convenient. And it's for example, using things like he's going to show an adapter. Again, there's so many appliances that need those 3-prong. And what happens is it's very common for flippers to try to fool the system by taking those 2 prongs out and putting a 3-prong in by making connection from the grounded conductor up to the equipment ground. That will fool those little 3-light dummy testers. If it's a sure test, by ideal, a higher dollar type of tester, then it will detect a bootleg, okay? So typically, if you have no equipment ground and you use one of those 3-light dummy testers, we call them, then you should get what's called an open ground. Obviously, there's not one there. But people have done things to try to fool these different testers and fool home inspectors and things like that. I know you're not the folks to do that, but I want to make it aware of that. So I like what he's doing. He's going to be replacing this 2-prong receptacle device with a GFCI in order to add some additional protection and to be able to use 3-prong. To put a 3-prong device in there, which in this case will be a GFCI device. All right. So I'll talk about additional things as we go, but kind of want to set the tone up front with that as we get started.
To solve that, you might be using one of these adapters that takes a 3-prong and gives you that 2-prong, and it has an additional small strap here that actually some people screw in. So the screw for the faceplate right in the center here, they'd screw that in. Now that's not creating a ground because there is no equipment ground coming to this box. So it's just an unsafe way to do it. So let's get you upgraded to a 3-prong and do that safely. This is called out in NEC, and down in the description I'll put a link there for your reference.
course, we'll go to the NEC later and look at it at the end when we wrap this thing up, and I'll show you the different options this gentleman has, because I'm sure there's other receptacles in that room. So he wants to replace all of those, I'm sure, with 3-prong instead of this 2-prong. So we'll go over that as well. So just hang tight and we'll look at it piece by piece.
But all we're going to do is install a GFCI receptacle, which is the safe solution on how to upgrade this 2-prong receptacle. So let's jump in and get you upgraded so you're not fumbling around with these unsafe adapters and you have a safe 3-prong receptacle to use in your house.
Now remember, there's also the ability, let's say this is an older house and there was a service upgrade or a service change. If the panel is newer, but the branch circuits are existing and it's older, then you might have the option to put a GFCI circuit breaker in the panel, and it protects everything downstream and achieve this goal of being able to change out all these receptacles to 3-prong instead of 2-prong. Okay, so there is other options, but that only works if you have a panel that can accept it. In this case, it's an older home, so we'll assume here that it is not the case, and so the easiest solution for them is to put a GFCI receptacle in at this point. So kind of how that works. So just want to make sure we're following along and adding all the possibilities that you might run into. Again, a lot of old homes get panel upgrades, but they leave the wiring in the home. Again, whether it's cost, they don't have the money to do everything, depending on how it is. So you might have the option of a GFCI circuit breaker. Okay, he's going with the receptacle.
So the way we start off any of these electrical projects is to make sure we can safely work on this receptacle and there's no power going to that. To do that, I'm going to use a non-contact voltage tester. I'm going to turn it on and I'm going to test this receptacle to know that my voltage tester is working and power is still going to this receptacle. Once I've confirmed that, then I'll go hit my breaker to turn off power to this circuit. Then I'll come back in, and with the same voltage tester, I will test it again, confirming there is no power going to this receptacle. And once you do that, now we're ready to install the GFCI outlet.
I always start off with these old faceplates by scoring the surface between the paint and the faceplate.
That's a really good tip. Also, remember if you're opening up an electrical panel, that you want to do that same kind of score. Although I go in at a bit of an angle, shooting the tip of the blade back a little bit underneath the cover and letting it ride along the surface of the cover so that I'm kind of scoring it just inside. Because when you pull it off, again, we don't want to rip any paint off. And again, then I'm not a painter and I don't want to paint and I hate painting. So make sure that you don't create something else because, you know, it could be a nasty cover, nasty panel, nasty receptacle. But the first thing that the owner is going to look at is the fact that you pulled their paint off their wall, right? So, you know, it's one of those type of things. So again, I love the tip, score around it, make sure, because people paint. They don't always remove the covers. And then what happens is, you see here, they probably painted around it and then they wiped off the excess but didn't get it all because it got down in some of the grooves in the cover, that's textured cover. And so again, cutting around it, pull it away. You don't run the risk of peeling off any of their paint. You don't have to hear the moaning, groaning of that.
Then I undo the screw and carefully remove it to reduce any paint damage. Just double check in here to make sure that no power is going to the box. Then I'm removing the 2 mounting screws so I can pull the old 2-prong receptacle out. And we'll take a look at what we're dealing with. And here, you really only expect to see a neutral and a hot side. So I am going to take my micro side cutters and then just cut that off clean so we can strip new copper for the GFCI. GFCI and all receptacles really have a strip gauge that will show you how much copper you need to strip to properly install. You can use the strip gauge like this to reference your line, or what I do is I actually take my strippers and just get a reference on the strippers. So I know I need to strip to the 14 gauge mark on my strippers, take that mark, pivot strippers, and then strip that amount of insulation off. So I'll do that on the neutral and on the hot side. So we're ready to start wiring.
Okay, only a couple things I want to add here. Obviously, y'all know he meant strip insulation and not strip off copper. He was exposing the copper. Couple things. The National Electrical Code required, and this is older, so it probably predates that, but it requires us to have at least 6 inches of free conductor as it enters from the cable into this box. And I'll say cable because this is a metal box, so the chances are that is old BX cable back in that wall. Remember, BX is not the same as AC cable, and it's certainly not the same as MC cable. BX was an experimental GE product from years ago. It's been used a lot in older homes. The armor on the old BX is not the same as AC cable. It's not an equipment grounded conductor. If it was, then this wouldn't be 2-wire, right? The BX predates when the equipment grounds were required. So just because it's metal, don't think you can use that as an equipment ground. Flippers want to do that all the time because close proximity to a panel, it might read out as being a connection to ground as it connects to the panel, and then they end up wanting to use it. BX was never intended for the armor to be used as an equipment ground. AC cable, which is under Article 320 of the NEC, that is specifically designed to use the armor as an equipment ground. That way you don't have any equipment grounds inside of the cable assembly, okay? Because you're using the armor and you use a special fitting that's listed for use with the AC cable in conjunction with the metal box. Now, MC cable, metal clad cable, doesn't have the armor used on traditional MC, doesn't use the armor as an equipment ground. You have a equipment ground inside the cable, right? Either green insulated or bare. It doesn't matter. UL 1569 doesn't care. Most manufacturers with this smaller branch style MC will put an insulated green equipment ground. As it starts getting larger into feeder size MC, it tends to become bare. But the code allows for it. Not a problem either way. But the big issue is the armor on MC cable is not to be used as an equipment ground. That's the traditional MC. Now, they do make smart products, or like we say, advanced, enhanced type of MC, where the armor can be used as an equipment ground. And that typically goes up to 6 gauge and doesn't get any larger than that. So it's not the large feeder type MC that can get that smart ground, or Southwire has one called MCAP. Encore Wires is called Smart Ground. That has a conductor that runs, it's aluminum, it runs through with the insulated conductors, and it makes an intimate contact with all of the armor. So when it gets to the end, you just take that aluminum grounding / bonding conductor, you cut it off. You don't do anything with it. You don't take it in the box, you don't terminate it, you just cut it off. And then you put the proper MCI-A fitting on top of it, and then it makes intimate contact with the armor, with the fitting, and with the box, and you're done, right? Totally different than the old BX style. That was not for use in any of that armor as anything to do with an equipment ground. So again, older homes like this probably is an old BX style armor. Just remember, just because it's armor doesn't make it an equipment ground, okay? There is a difference between AC cable and MC cable, and BX is neither. Okay. Although it's very common for people to say BX, BX, BX when they're talking about AC or even MC. It is not the same. Okay. Want to throw that out there. Secondly, cutting those shepherd hooks off the end bins, cutting that off when they could have probably been reused. The chances are they weren't damaged. I would have taken the screws all the way out, just worked them all the way out so they fall out the device, and then looked at it and either straightened it out, or you could have cut it off. But again, you want to preserve the length that you have because you need it. This device is rather deep, right? The GFCI, and I have to have enough room to work with it. One of the things that I like to do is when I if I were to cut off the receptacle like that, or if the ends were too damaged and I wanted to replace it, then what I would do is splice on pigtails so that I could take that older, probably a cloth type of insulation, really old, and I can train that back into the back of the box. And that way I'm not tugging and pulling on any of that cloth or whatever. It's probably brittle or crack off. For me, I want to have less stress on that. I don't want problems that an electrician have to come back and deal with anything. So I would splice on my pigtails of the fresh new wire. Maybe I stripped it out of some non-metallic sheath cable or what have you. And then I wire nut them on here to extend them. And then I tuck and fold those nice and neatly back in the back of the box. Now I've got enough free conductor to work with my device. I don't have to work real close to the wall. I can do everything nice And again, just makes it much easier to work. Again, you do you. I'm just giving you some commentary. I do not like working with little teeny pieces of wire sticking out of the box. I don't. That's just me. Okay. Just wanted to get that out of the way.
Now you'll see we're only using the line portion of the GFCI. The load portions underneath this label for this instance will not be used.
Now remember, if you're doing this, and we'll look at the code later, if this is the first receptacle and there was more than one cable in the box like he's got, if it was going to multiple receptacles downstream, then you would be doing the line in from the source, and the load would be what's going out to the other receptacles downstream. So you're feeding into the device and then out of the device downstream. In this box, he's only got 2 wires, so it's either at the end of a loop, or this was a branch circuit that's only one thing was run in this one. All right, or maybe this is the only receptacle that he's wanting to do that, and who knows what the other ones are. But again, bear in mind that since there's only 2 wires here, this is either the individual branch circuit to this location, or it's at the end of an existing branch circuit, and this is not going to do anything for the receptacles upstream. It's only going to protect this receptacle, and since he's not running any downstream, he's not using the load side of this device, then this is either the end of the line or whatnot. So just keep those things in mind. But we will talk about what to do when I have multiple receptacles in a room a little later.
Gold goes to black, which is hot. And then white, or the neutral line, will go to the silver screw terminal. Now you'll put the straight strand of copper underneath the plate. You do not need to make a J-hook. And then you'll tighten down the plate to make a secure connection. So we did that for the hot side, and now we'll just do the same thing for the neutral side.
Now, whether you like it or not, some of these devices will have this. Some of them will have a back wire, because 15 amp typically have a back wire. You won't get back wire on 20 amp. I see this looks like a 15 amp GFCI because it doesn't have any T slot on the neutral side. But at the end of the day, one of the things that I like to harp on, and again, it doesn't get done. I get it. But you're supposed to be using a torque screwdriver. I know, I can hear what you're saying out there, and I can understand when everybody out there goes, Paul, be a practical guy. I'm sorry I can't, because for years I used a torquing screwdriver, and my torquing screwdriver was nice. It worked like any other screwdriver. All I did was set it to my value, and it would snap when it gets to the proper torque. Studies have been shown that the majority of the failures in a circuit come from poor termination. That can be over torquing, that can be under torquing. Even something as simple as devices. So I encourage you, get a torquing screwdriver and treat it like your regular screwdriver. Okay, I'm just saying. Now, you do you. I'm just giving you commentary. Okay, you could say, yeah, I get it, Paul, but you don't do it anymore, old man. Trust me, I did it. Google it. I'm just telling you what the code says, and it's a minimum safety standard. Can follow it if you don't. You want to, whatever. But he should be torquing these, okay? But we'll let him do him.
Underneath the plate, making sure no exposed copper is going past the housing.
Notice how hardly any room to work
Now,
with this.
before placing a GFCI outlet in the metal box, because it's so tight, actually going to wrap with 3M Super 33 Plus electrical tape. Best tape on the market. And you can see the link in the description, which will show you exactly what I use. I'll do 2 wraps, stretching the electrical tape as I go on the outside, and that will help bond the tape and also contour to the receptacle housing.
So this is not required by code. This is very common. People that work in commercial like to do this a lot. It's actually designed with the screw is the mounting screws that it can't, the side of the device could not get to the edge of the box. Again, it is a bigger deal when you have a bunch of equipment grounds in a box and you're tucking everything back in the box, and I get it. But it's really designed so it should not touch the side. There's absolutely nothing wrong with adding the tape. Again, go for it. If you want to do that, it's a preference if you want. I installed many boxes and devices in metal boxes and never had the issue, and I did not wrap with tape. But feel free to do so if you want to. That's perfectly an acceptable practice for you to do so if you would like to. Okay. Now, I'll also remind you, See how close he is to this wall with this device? And there's a lot of movement on those conductors. If this is one of the houses like I used to work in that was the old knob or the old cloth, it would start to brittle and crack with even those movements. So once I take that first device off, I usually would splice on pigtails and then neatly get those conductors back so that all I'm working with is those fresh conductors. It only takes a second. That's just me, because usually what happened, it was nothing about the terminals touching a metal box. It ultimately ended up problem was back on the old insulation brittly cracking off as you're pushing that device back in there, and it ends up bending up and touching the side of the metal or something like that. So I always worked very gingerly around the old insulation in there because it was probably old and brittle and things like that. So again, you start moving it around a lot, it will crack. And if it cracks at the fulcrum back where you're bending it, it could touch, the black and the white could touch and you get a dead short. So just me, but nothing against what he's doing. I'm saying I like the pigtails. I like to get me a little bit of pigtail on there.
And then at the end, instead of stretching it, I will just cut that off with some micro side cutters, because at the tail end of the tape, you don't want to stretch it. You actually just want to lay it back down and adhere it to the wrap. Just a couple more screws and we'll be done. So we'll reinstall the mounting screws. I work back and forth, and then also make sure that the receptacle is centered so you don't get done, tightened, and it's kind of cockeyed in the box. Now once you have that tightened down, we'll do a standard Decora faceplate and then tighten down both of the screws. Then we'll test it out. So go hit your breaker back to the on position, and we'll press the reset button, testing with our voltage tester. Everything looks good. Also use an outlet tester where I only have the center LED on, which does mean open ground, which is expected.
Okay, all that's true. I would expect an open ground because they're in the ground there, obviously. How many OCD electricians out there are looking at those screws and saying, really, dude, one is vertical and one is horizontal? It's an electrician thing, but again, screws. If you're going to be all vertical or horizontal, make sure you're consistent with it. Again, is that a code rule? Absolutely not. Is that a pet peeve of so many electricians out there? Absolutely. No different than the ground up or ground down. All right. If you ever notice that the buttons and everything are written so that it doesn't matter which way you put the receptacle, ground up, ground down, doesn't matter. The code doesn't care in this case. But again, those mounting screws, OCD, baby. I like to have all of mine when it comes to receptacles horizontal, and all my switches were vertical. It's just me. Does it matter? No, it doesn't matter.
Because of that, NEC does call out that we need to label a no equipment ground sticker on the faceplate, and the sticker will be found in the GFCI box so you can use it.
So not too bad, right? Something you can knock out pretty quickly, and it's just so much more functional to have, and safe, to have this GFCI 3-prong. So if there is a fault there, this will actually trip. It doesn't have the ground return path, which is ideal, but if there is a fault, it will trip because of the design of the GFCI outlets.
So GFCIs work because it's looking for the imbalance of the draw of the current between the hot and the neutral. Typically, GFCIs work on what's called, we call it a 5 milliamp nominal, but the standard calls for it to be 4 milliamps or less, or 6 milliamps or greater. So 4 milliamps or less, it will not trip. 6 milliamps or greater, it will trip. So that is leakage current, not traveling back on its intended path. All the circuits traveling through the toroidal coil in order to not create a magnetic field that can cause the action of the GFCI to function, keeping it very high. We don't want to go. We'll save that for another video. But that's how the GFCIs function. So if the path back to the source is outside of that coil, then it's no cancellation effect takes place and it creates a magnetic field and it causes the GFCI to function. So if the path is through you, GFCI functions, okay, very quickly. If everything's good, everything's traveling the way it should, then you don't have any GFCI activate and everything is fine. Now, GFCI devices come in different classes, Class A, Class B, Class C, Class D, Class E. We have the GFCIs like this are Class A. and that is the 4 to 6 milliamps we call 5 milliamp threshold. And then, of course, we have Class B, which is typically 20 milliamps or 30 milliamps, depending on the manufacturer. That is not going to protect people. That's more for protecting property and equipment that's connected to it, things like that. And then it starts getting into things we call special purpose GFCIs, and again, for three-phase applications and whatnot. So again, a bunch of different classes of GFCIs that we have. So again, he had some options here. So I think he's going to talk a little bit about the options, but in this video, he's only putting that one receptacle in. That's it. And so that's the only receptacle that he could change to a 3-prong, and he used a GFCI device to do that. We're going to look in the code that gives you 3 different alternatives on what you can do and how you can do it, and the labeling, because the labeling he did there, which was, I think it was no equipment ground, right? That's only going to apply to this receptacle here, okay? Now, if he uses the load side of this receptacle and feeds downstream receptacles, then there's a little more labeling he has to do. Typically always supplied by the manufacturer of those GFCI devices, but just be aware of that. So let's go on and see what he has to say, finish it up, and then we'll go look at the code.
Now this was a very straightforward, right? 2 strands coming in, neutral and hot into the box. If that solved your problem, awesome. Thanks for watching, and don't forget to subscribe before you take off. Now, if you opened your electrical box up and you just saw way more wires than what we showed here, which were really just those 2, it's about as simple as it gets. Don't worry. For one, if you feel unsafe and you're uncertain, call in a professional. At least you know what you need now, so you can walk them through exactly what you're looking for, hopefully get that done in a timely manner and for a reasonable cost. But I will mention that if you have multiple receptacles in a room and they're daisy chained together, one after another, there is a possibility where you can install one GFCI at the start, and then you can take the load lines from the GFCI, which we talked about but we did not use, right? And then connect a normal receptacle downstream of the GFCI, and it still is protected by the GFCI, and it's still following NEC code, even though it will look like a normal receptacle.
Now remember, when he's saying normal receptacle, folks, we're talking about today. So this would be the receptacle called the grounded type. Means it's going to be 3-prong, and it's going to have an green equipment ground terminal on the device. Okay, that's when he says normal receptacle. They're called the grounded type receptacles today, right? 3 prongs for short.
Opposed to a GFCI. Now again, getting a little more complex, but I just wanted to let you know that if you have 3 or 4 receptacles in a room, there is a possibility if you install a GFCI at the starting receptacle that you could just install standard receptacles at the other 2 or 3 and you would be covered. Now you still will need to label that there's no equipment ground on that faceplate to follow NEC. Now if you have any questions, jump down in the comments, and myself or many of the viewers who are very active would be happy to help you and at least give our 2 cents. But be safe, and we'll catch you on the next video.
Okay, let me go on and give this, and we'll look at the code real quick to end up on code. I thought he did a good job. I thought he hit all the key points that were important. He threw in some extra about the tape. He's probably doing like a service call type of thing. So again, nobody's going to be going behind him to make sure he has a certain number of free conductor and all that. I gave my commentary on that. At the end of the day, though, I'm going to give him a 5 out of 5. I think he did a great job in conveying an accurate message to the end do-it-yourselfer or the homeowner or the whoever. I think he did fine. Now, we want to look at the code to kind of wrap our head around the options that you have. If you're going into a home and you're going to replace a receptacle like this, that's a 2-prong, or what we like to say a non-grounded type receptacle, then you want to see what your options are. Okay, so let's go on and look at the code really quickly, and we'll look at those. So I'm at the NEC. I'm using Link. Link is a product from NFPA. And we're at the replacements. So here at the beginning of this is general installation requirements 406.4 for receptacles, okay? And so again, obviously they have to be the grounded type, and it goes on and says, well, what about if you're doing a replacement? So if we're doing a replacement like what he's doing, it says replacement receptacles shall comply with 406.4 D1 through D7, so different options here, as applicable. Arc fault circuit interrupter type and ground fault circuit interrupter type receptacles shall be installed in a readily accessible location. So one of the options is if he was replacing this receptacle in a location that back then did not require AFCI or then did not require GFCI, if the location now requires it, then you're going to have to do something different. It's just not as easy as a swap for you, okay? Now, we'll just say that this is just, and we'll do that in a different video. Let's just say that this is a location where he can simply swap out that 2-prong and put in his GFCI like he wants to do. Okay, so I will show you real quick. There's D1. We're going to be looking at D2 because this is originally a non-grounded type. But just to show you, there's rules for D3. That's for GFCIs. Here's rules for D4 if you have AFCI. Here's a rule for tamper resistant. So if you're removing a receptacle in a location that now requires tamper resistant, then guess what? It's got to be tamper resistant, okay? You're putting it back, okay? So again, just kind of laying out those rules. All right, so let's deal with his real quick. So non-grounded type. You see that we have an A, B, and a C there. So we're at 406.4D, and there's a D2A, a D2B, and a D2C. Now, the first thing that you could have done if you're a service electrician and you're just going out to a job and you have a damaged 2-prong receptacle is you could just simply replace that 2-prong with another 2-prong, okay? A non-grounded type. The code allows for that. It was okay at the time it was originally installed, so I'm going to allow you to put it back the way it was. But people want the 3 prongs for convenience, plugging in things. They want it. But we don't have an equipment ground there. Now, granted, you could rewire it and now run brand new branch circuits and add equipment grounds, and you could follow some rules in 250.130 that would allow you to get an equipment ground there. But you're not doing that. At this point, you're like, okay, I want to give them some level of protection, but I want also to give them 3 prongs, so it's very convenient in a lot of the appliances and things that plug in today. So you go the route that he did. And if you look at the code, the first one, again, A, is 406.4D2A. That's just a like-for-like swap with a regular non-grounded type 2-prong receptacle. Simple. Like for like. Okay? Now, B is a little different. This is one that he did based on his video. It says, non-grounded type receptacles shall be permitted to be replaced with a ground fault circuit interrupter type of receptacle. That's what he did. Okay? It says these receptacles or their cover plates shall be marked no equipment ground. And that's what he did. He put the little label that comes with the GFCI. He's good. It says, then it goes on to say, an equipment grounded conductor shall not be connected from the ground fault circuit interrupter type receptacle to any outlet supplied from the ground fault circuit interrupter. So if you're extending from that one onto another one and you're thinking, oh, well, now I'm going to use the right type of wire and cable that does have an equipment ground. No, you're not going to be using the equipment ground into it, okay? You want to make sure that you don't connect anything at this point to anything that might be going downstream of this receptacle, this GFCI receptacle, if you're using it in this fashion, okay? And it tells you that point blank. Obviously, the GFCI is not establishing an effective ground fault current path. So connecting anything beyond that to the green screw on it and going downstream to other receptacles would be misleading and it would be false because you're not going to be establishing an equipment ground, an effective low impedance ground fault current path. You're not going to be establishing it from the GFCI. It wasn't there to begin with, so you're just not going to use it, okay? All right, so that's what he did, and he stopped right here. Now, one of the other options that you have here is item C. And that is, you could have installed, like we said earlier, you could have installed the GFCI circuit breaker if the panel can accept one. Okay, so maybe you had an upgrade. And then all receptacles downstream from that are considered protected by the GFCI feature, right? There is still no equipment ground. There is no effective ground fault current path, but you do have this level of leakage current protection afforded you by the GFCI device. It's better than nothing, okay? So that's what you're doing here. So the little difference in this one is, let me read it to you. We're at C now. It says, a non-grounding type receptacles kind of what was there, the 2 prongs, shall be permitted to be replaced with a grounding type receptacle where supplied through a ground fault circuit interrupter. So when it says supplied through, that means I take the 2 prong out, I put the 3 prong in, the grounded type, and if I have a GFCI circuit breaker, it's protected through that circuit that's supplied from that GFCI circuit breaker. That's what it means, supplied through the GFCI device. Okay, so that's what that means. Now, in his case, it also means that if he had to put that GFCI receptacle in the first receptacle location that's being supplied from the panel, that's the first outlet location, an outlet being the box, not the device, not the GFCI, that's a device. It goes in that outlet box. If that's the location and I put my GFCI receptacle there, then every receptacle that might be on the load side downstream, if I'm doing the rest of the room, those would also be GFCI protected because they're coming out of the load side of that GFCI device. But instead of just putting a label on there that says no equipment ground, on all those receptacles that are supplied from the GFCI device, they have to have GFCI protected put on them, and they also have a label that says no equipment ground, just like the one if you just put a single receptacle in like he did. So if you're going to be protecting any downstream from that device, then it's going to need 2 labels on it. One that says GFCI protected, and one that says no equipment ground. Okay, and they have to be visible on the actual cover plate or the device. Okay, so typically, that's what you'll see. Do they get peeled off by the owners later? It is what it is. But for a compliant installation before the electrician walks away, that's what they need to do. Okay? So all of this is being done, right, with no equipment ground present. And it's still going to be a safe and effective means of doing this. The code allows you to do it. Just remember, if you're doing a receptacle replacement in a location that now requires GFCI and it didn't then, or it requires AFCI and it didn't then you're going to have to put in and protect it with AFCI or GFCI. Okay? And we'll cover that in a different video if that's confusing. But we really just wanted to talk about the ability to go from an old 2-prong style to a newer grounded type 3-prong and what the options that you have. So hopefully you got something out of this. Again, I thought he did a great job and he's helping educate people out there. So until next time, folks, stay safe. God bless.